The DevOps Whiteboard. Here's a developer, or a team of developers, or a company who've had a really good idea about a piece of software or an app that they'd like to deliver to an end user whilst getting meaningful feedback about how it could be improved and how it could work better. But there are problems. More often than not, the delivery process is largely manual, with bits of script, bits of mental knowledge, bits of programs, all wired together to deliver this software out to the environment. And often the feedback loops are manual as well, on a kind of best efforts basis. So sometimes the feedback may not even make its way back to the developer at all. Secondly, there are infrastructure issues. The environment we want to deliver to may not be available, or components of it may not be available. Or worse, there may be an environment, but it's not at the right level, not at the right application patch. And consequently, we're delivering something to an environment that's unrealistic. Then there's the need for speed and agility. A good idea is not a good idea if delivered 2 years later than your competitor. So we need to be fast wherever possible, and we need to try and avoid waste. So this brings us to the 4 main areas of DevOps: collaborative development, continuous delivery, continuous testing, and manage and monitoring. In this presentation, I'm going to focus on the middle two, continuous delivery and continuous testing, to describe how they together make a kind of factory whereby different versions of the application under development come down a conveyor belt and make their way out into release. On the way, going through build, provision, deploy, and test. So let's have a look at these 4 areas. Starting with build. In a DevOps context, build means continuous integration. This means that when a developer who's written a new bit of code checks it into his code repository, the continuous integration engine automatically takes that change and rolls it up into a build with any other changes, integrating it with those changes. The result is then unit tested or tested to whatever level is required, and then, should it be of sufficient quality, packaged, published, and dropped into an artifact repository for subsequent consumption. All of this done in an automated manner. The next stage is provision. We've already mentioned that the deployment to environments is tricky because those environments are difficult to create. In a DevOps context, this is taken, and instead of doing it manually, the nodes, the different components of the system under test, are defined in terms of their compute power, the storage required, and any network connectivity. And this definition is stored in a kind of manifest for each of the nodes, and then they are published in a set of catalogs to users or groups of users. These users can then look at that catalog, choose the environment they need, and automatically have it instantiated in some kind of hypervisor technology like VMware. Optionally connected to an external data source, they continue testing the way they always did. This process is very much hands-off for the end users, automated and simple to use. So now we have a build of the software ready to go, and we have environments where it could potentially be deployed to. So now we just have to look at how DevOps treats the deployment process. The twin areas of deployment automation and deployment orchestration together make up the continuous delivery engine. This engine can either receive pushed artifacts from a build or continuous integration tool with a quality status attached, or pull them directly from an artifact repository. The deployment engine then needs to deploy these to the DevOps pipeline. This DevOps pipeline has been created through the provision mechanisms we saw just earlier. In my example, there's a development environment, a systems integration test environment, a user acceptance test environment, and a production environment, the latter 3 all controlled by quality gates. The DevOps engine is then used to take the artifacts and use them to create a deployment process. And when this deployment process is judged to be correct, the process itself is snapshotted and turned into an artifact. This artifact can then be promoted through the different versions down the DevOps pipeline. Now this has 2 benefits. Firstly, it's a much more efficient and simple way of moving the software, deploying the software to the different releases. but also it tests the deployment process. So by the time we get to production, we're pretty darn certain that this deployment process is going to work. This takes us on to the last area, continuous testing. Now, continuous testing in a DevOps context means automated testing largely, and there are various ways we can do this. The environment I am talking about is a client application which talks to a front-end web server. Perhaps that web server puts its jobs into a queue manager. That queue manager then distributes them to applications running on an app server, which stores the records in a database. Continuous testing consists of an automated approach to testing. And the first level is functional testing. An automated functional test tool will allow you to create user journeys at the client user interface to verify that the functionality works. These automated tests can be rolled up and run as part of a continuous testing approach. Next, we have integration testing, similar to functional testing in that we're testing the functionality of components of the application under test, but not interested in the user interface. Instead, integration testing is interested in the interfaces between different components. So, for instance, the web server may be providing services to the client application, and I can use an integration test tool to test that the messages that are sent and received from that web service behave according to the rules. These integration tests can be rolled up as part of a continuous testing approach. Next, we have performance testing, which is often ignored. Performance testing involves making sure that everything downstream of the client application is able to respond in a reasonable manner in terms of its response time. So we want to apply a reasonable, realistic, representative load using a performance testing tool and measure the response times. This can also be automated and rolled up as part of a continuous testing approach. Lastly, we have service virtualization, which is not strictly a testing tool, but is very important in a DevOps context. In continuous testing, we need to be testing as early as possible, and often the full environment isn't available. What service virtualization allows us to do is create intelligent stubs that represent missing components of the environment. For instance, the app server may not be available, so we can create a virtual version of it that allows us to continue testing the web server and the queue manager. This concludes the DevOps Whiteboard.